Hey guys, this is Dan with Pacific Tech Center, and today I'm going to go over my second revision of the GET-VPN Lab for you. It's very similar to the previous one with just a few differences. So let's get right into it. We'll go ahead and set it up. We'll run the script. And once this thing's done, we'll go ahead and start it and get into it. Let's go over this a little bit. We have two key servers, key server 1, key server 2. Each router has the .1, .2, .3, .4 as the last octet, no matter what segment it is. And as you can see, I made the second octet related to each individual router themselves. So key server 1 is 1.1, key server 2 is 1.2, member server 1 is 1.3, and member server 2 is 1.4. I need to first make sure that the routers are up and communicating before I go to the next stage. So we'll go ahead and we'll work on the first key server. Once this thing's up, we'll do a connectivity test. But we'll go over this a little bit. If you haven't looked at the scripts from my previous videos, I set up a class library in Python to make it easier to design a lab graphically through the script. So you can basically say this object is here and then move right one or move down one or whatever, and allow you to organize how the diagram looks. As you see right here, you know, key server 1's to the left, the key server 2. Then we have the MPLS emulator, the switch, if you will, right below it. And then you have the two member servers over here. In the script, I also turn around and I set up two users and then two different branches. So you have branch 1 over here, branch 2 over here. You have user 1, user 2, and then everything's pre-set up. So the connectivity is not part of this lab, it's really just GET-VPN. So let's go ahead, and everything should be up now. So let's go ahead and get into the document again and make sure. Yep. Okay, we'll go ahead and log in here and ping all the different routers and make sure that we can communicate with them. Connectivity is always important before you start, because if there's anything we have to troubleshoot, we need to troubleshoot now before we set up GET-VPN. And I state that right here, so there you go. Really, in the lab, we don't do too many things to keep it secure unless that was truly the goal of that lab. But I'm trying to get everyone with more muscle memory as far as deleting default ISAKMP and IPsec profiles and policies. That way, you know, everyone can be used to having a more secure configuration. Instead of making use of default configurations, you specifically set your ISAKMP and IPsec information. Everything else is insecure. It's just muscle memory is the whole point here. So let's go ahead and do that, and we'll set up the first key server. and get rid of the default policies and profiles. And now let's set up the first ISAKMP policy, which is AS128 as an example, and SHA-256. We're going to use group 14 and lifetime 400. Pre-share keys for this particular lab. At some point we'll do PKI and go for a more secure environment. And then as I stated, not everything is secure, such as using the same key for all addresses. As usual, any sister company that you have, or vendor or customer that you have that you're going to do ISAKMP connections to, you would want to use different keys for each. And here in this case we're just using the same very simple password. There's nothing secure related to this key password, as you can see. The IPsec, we're only going to be doing IPsec on the key servers, because the key servers are going to transmit the IPsec transform set as well as the profile to the member servers. This is not something that we'll have to configure on the individual. So we'll do SHA, HMNC, and this is not a transport based configuration, so we don't have to change this to transport. And let's go ahead and set up the profile, and that's going to be PF1, and we're going to set up the transform set to XF1, because these are the two things that are going to be sent to the member server. And then we're also going to change the security association lifetime to 7,200 seconds. Okay. We'll go ahead and set up the key server specific information. And this is basically setting up the RSA keys so we can assign keys. And then also the GDOI configuration has to be specified on the key servers, with more details on how to rekey and what have you, and also telling it how to do the COOP protocol. You know, when you have multiple key servers and two key servers communicating with each other, they've got to use that to keep track of each other. So we'll go ahead and set that up now. First, the key. And we're going to label this because this is specific to this protocol. This is not going to be used or later on we would use a more generic key for SSH or whatever, or you know, whatever we're generating for it. In this case, this is specific to GDOI. We're going to use group 1. And just like on the DMVPN, we use tunnel 123. We're going to use identity number 123. We'll set up the local server information. First, we'll do the transport, and we'll set it up for unicast. You know, as they say, don't trust everything you hear until you've tested it out and proved it. And one of the statements is that supposedly in a large deployment, multicast is supposed to be better than unicast, use up more bandwidth, whatever. I don't know until I test it. So right now, at this point, this is really just hearsay to me until I actually test it. Go ahead and set up the lifetime of this, and for more stable, having more of a stable connection, we're going to make this once a day instead of, like you saw previously, 7,200 seconds or 400. We're going to make this once a day when it establishes the IPsec. Or I mean the GDOI. Sorry, GDOI information. So we'll do that. So it only read keys once a day. And we'll retransmit. And then the address will be this key server IP address is 200.1.1. And here's where we define the IPsec information that will be transmitted to all group members that become a member of this GETVPN group. And we also have to set up the encryption domain. The encryption domain is the encryption domain is going to be what communicates between these branches in this case, because the encryption has to be when communicating from one device on a group member server to another device on the group member server. If you encrypt something and somehow the destination is going to a router that's not a group member, that router is not going to be able to understand the encryption information. So it's important to make sure you have defined what is the encryption domain and what isn't. We'll make the window size 5. And then redundancy, we'll have to set up the information about, is this the primary or is this the secondary? In this case, we're on KS1, which is the primary. So we're going to give it the highest priority possible. And then we're also going to tell it, well, what is the peer IP address? Who is the other router that's going to, or key server that's going to be part of this? And this is the IP address of the key server number 2. And now we have the COOP protocol working. We can go ahead and set up the access list for the encryption domain. And we'll just say it's a 16-bit address. Anything 10.1.x is going to be in this encryption domain. It could also be stated as interesting traffic. And there's a couple other ways to define it, but in this case I'm just going to use encrypted domain. We have almost everything set up for this key server. Let's go ahead and set up the second one, and then we'll set up the member servers. Once we had that first key server, we could have done the group members. So you don't really have to set up all the key servers up front, but we're going to do it in this case. We'll get rid of the default policies and profiles. Go ahead and set up ISACamp, the first policy. AES 128, SHA-256, group 14, lifetime 400, authentication is pre-share. We'll go with the same key for everything we communicate with for this lab, and then we'll set up the IPsec information. So using XF1, AES, ESP, SHA, HMSC, we're not using transport mode. And let's set up the IPsec profile, which is just setting up the transform set information. We'll do lifetime of 7200, and we're done with that. Let's go ahead and set up the GETVPN information. So the first thing we need to do, just like on the first case server, our key server, is to set up the key to be able to sign. And then we'll set up GETVPN. Set up the read key information, transport, again unicast, and then use the RSA key for signing, and then lifetime is going to be once a day. We'll retransmit on 10, and of course the IP address of this router is 201.2.2, and we'll set up the IPsec to match what we did on the first key server. GET-VPN ACL. Windows size 5. We'll set up the redundancy now. And this is the secondary one, so we're going to do lower priority. Of 5. It's a real simple number. I'm going to cut it in half. Guaranteed to be the secondary at this point. And we'll set up the secondary or the primary IP address, and now the access list. We'll match what we did on the primary server. 16-bit network. Now we're done for now for the key servers. Let's go ahead and go to the group members. So just like the key servers, we still have to set up the ISACMP information, and we'll remove any of the default profiles and policies. Okay, now let's skip all the way down here. We don't have to do any of this for the member servers. Keep it simple, and we'll just set up the GDOI configurations, which is really just the ID number and the server IP addresses. And the moment we assign the crypto map, we define the crypto map and then assign it to the interface, it will enable the encryption. So you see here, all we have to do is define the group. And we may or may not have to assign the interface for this. I'm doing it here just as an example. It'll still work without it. But this part is when you define the crypto map on the interface. It's the moment I hit enter, you're going to see that it becomes a member of the group, the GDOI group. There you go. And if we look at the details, we will see that it notices, or it knows about both the key server 1 and key server 2. There's 1, there's 2. And if you look at more details, down below, you'll notice that IPsec is also shared here. And even though we have no IPsec information defined anywhere in this configuration, there's still an SA. And that's because it was all that information that we did on the key servers was pushed to this group member server. So let's go ahead and set up the secondary group member. And again, all we need is ISAChem and the GDOI configuration, and we'll instantly, and the crypto map, and we'll instantly be in this configuration without having to do anything that we would normally have to do for VPN tunnels. So much easier configuration when you have a large deployment. You have 50 branches, 80 branches, I don't care. Look at how much simpler it is to set up each group member. Go here, tell it where to find the servers. And if you take a look here, you'll see that the IPsec information is defined, and we have an SA now. However, there is no encryption at this point, and that's because the encryption domain is between these branches. It's not between the routers and not between the key servers. So until these devices communicate with each other, you will see 00 for everything. So let's go ahead and we'll play around with that a little bit and demonstrate. We're not done yet, but we're close. So here we have 10, 1, 2, 100 as user 1. And 10, 1, 1, 100. So let's go ahead and try ping 10, 1, 2, 100. We're not getting a response. And if you look over here, you'll also see that the encryption was not performed. You'll see all the hit counts at 0 still, even though we tried to ping. And that's because the routers still need to know how to get this branch over to this branch. And they need to have the routing information. So let's go ahead and set up EIGRP, and that should change that for us. We'll do the encryption domain first. We can spell that word correctly. And then we'll set up the interface of the group member server to advertise the IGRP. And let's go ahead and set up the router ID just for kicks. You see that we have a neighborship with gig 00, but it still doesn't know about this guy because we didn't set up ERGRP on that one, so let's go ahead and do that. Just like the other one, we're doing the encryption domain, and then we'll set up the interface. And as usual, muscle memory, right? You don't want to advertise the IGRP to user interfaces, so it turned on passive interface where the user computers are connected. Now we can see both the 10.1.1 segment as well as the 10.1.2 segment. So now these users should be able to communicate with each other after all. Before I do that, one more time, we'll look at the packets that are encrypted. Make sure it's still 0. And still 0. We'll go ahead and ping the other guy. 10.1.1.100. We're getting a response this time. We ping 3 times. Let's go ahead and look at the count of the packets that were encrypted. There we go. 3 encrypted, 3 decrypted. Well, anyway, guys, this does complete the lab. I hope you liked the material. If you like it, thumbs up. If you don't like it, thumbs down. Please subscribe and hit notification if you like this type of material. And mahalo for watching. Thank you.